Welcome back. In front of us, we have a question that reads, the energy necessary to change 2.5 kilograms of ice at 0 degrees Celsius into water at the same temperature is 835,000 joules. What is the specific latent heat of fusion of water? Solution: we have ice at 0 degrees Celsius that is to be converted to water at the same temperature. So that is water at 0 degrees Celsius. The energy that is required, that is Q, is 835,000 joules. So we want to know the specific latent heat of fusion. The formula that we have to use when we are dealing with phase change is that Q is equal to the mass times the specific latent heat. In this case, we are dealing with latent heat of fusion, so that will be L sub F. F indicating that we are dealing with fusion. So L sub F is specific latent heat of fusion. If it is V, it will be for vaporization. So Q is 835,000 joules. This is equal to the mass given in the question is 2.5 kilograms times LF. So that is 835,000 is equal to 2.5 LF. To find the specific latent heat of fusion of water, we divide both sides by 2.5. So this will cancel this. 835,000 divided by 2.5 is 334,000. This is equal to LF. So therefore, we can say that the specific latent heat of fusion of water is equal to 334,000 joules per kilogram. The energy necessary to change 1.5 kilograms of water at 100 degrees Celsius into steam at the same temperature is 3,390,000 joules. What is the specific latent heat of vaporization of water? Solution: we have water that is at 100 degrees Celsius that is needed to be converted to steam at the same temperature. So that is going to be steam at 100 degrees Celsius. So whenever you have a situation like this, it means that you are dealing with a phase change. Water at 100 degrees Celsius is to be converted to steam at 100 degrees Celsius. We are asked to find the specific latent heat of vaporization of water. The formula that we have to use is Q is equal to M times the specific latent heat, but for this case, it will be the specific latent heat of vaporization, LV. The quantity of heat that is given in the question is 3,390,000 joules. The mass is 1.5 kilograms, so Q is 3,390,000 joules. This is equal to the mass is 1.5 kilograms times LV. So we're going to have 3,390,000 is equal to 1.5 LV. So to find the specific latent heat of vaporization, we divide both sides by 1.5. This will cancel this. 3,390,000 390,000 divided by 1.5 is 2,260,000. So this is equal to LV. Therefore, we can say that the specific latent heat of vaporization of water is equal to 2,260,000 joules per kilogram. So what does that mean? It means that to convert 1 kilogram of water to steam at the same temperature, it requires 2,260,000 joules of heat energy. Calculate the energy necessary to change 1.5 kilograms of ice at minus 5 degrees Celsius into water at 40 degrees Celsius. The specific heat capacity of ice is 2,100 joules per kilogram per Kelvin. The specific heat capacity of water is 4,200 joules per kilogram per Kelvin. The specific latent heat of fusion of water is 334,000 joules per kilogram. Solution. The problem we are dealing with here is we have ice at minus 5 degrees Celsius that is to be converted to water at 40 degrees Celsius. So we want to know the quantity of heat, or simply the energy that is required to do that conversion. To solve this problem, the question that we have to ask ourselves is, what are the stages of transition that ice at minus 5 degrees Celsius will take to reach water at 40 degrees Celsius? We can draw the heating curve to illustrate that. So we have temperature in degrees Celsius against time in whatever unit. We're going to have the transition of ice that is initially at minus 5 degrees Celsius to ice at 0 degrees Celsius. Okay, that will be the first transition from ice at minus 5 degrees Celsius to ice at 0 degrees Celsius. So that is ice. Then from this stage, we're going to have ice at 0 degrees Celsius that needs to be converted to water at 0 degrees Celsius. So since it is a phase change, temperature remains constant. Okay, so we're going to have ice that is initially at 0 degrees Celsius here that will be converted to water at this point here. This stage is called the phase change. Okay, so this stage will be ice plus water. We have at this point just ice at 0 degrees Celsius, and at this point we'll have just water at 0 degrees Celsius, but in between there will be mixture of ice and water, having more of the water at the late stages. From water here at 0 degrees Celsius, the temperature of water has to rise to 40 degrees Celsius. So that is the temperature of water at 40 degrees Celsius. That is water here. So as you can see, we will have three stages. We'll have ice at minus 5 degrees Celsius to ice at 0 degrees Celsius as the first stage. Then from ice at 0 degrees Celsius to water at 0 degrees Celsius, that is the second stage, and the final stage will be water at 0 degrees Celsius to water at 40 degrees Celsius, which is the third stage. So we are going to calculate the individual energies or quantity of heat for all these stages. The total is what will tell us the total amount of energy that is needed for the transition from minus 5 degrees Celsius to 40 degrees Celsius. For the first stage, we're going to have ice at minus 5 degrees Celsius to ice at 0 degrees Celsius. That is from this point to this point. If you analyze it, you realize that there is change of temperature from minus 5 degrees Celsius to 0 degrees Celsius. So whenever there is a change in temperature, the formula that we have to use to calculate the quantity of heat is that Q is equal to mc delta theta. But in this case, that will be Q is equal to the mass of the ice times the specific heat capacity of the ice times the delta theta. Okay? So for the first stage, we are dealing with ice. So that is why be careful. The specific heat capacity that you have to use will be that of the ice and not that of the water. So many people will make this confusion. So going to the question, what is the specific heat capacity of ice? The specific heat capacity of ice is 2100 joules per kilogram per Kelvin. Okay, moving on. The mass of the ice is 1.5 kilograms times the specific heat capacity of the ice is 2100 joules per kilogram per Kelvin, multiplied by the change in temperature will be theta 2 minus theta 1. If you analyze the diagram, the change in temperature will be the transition from minus 5 to 0 degrees Celsius. So that is the final temperature minus the initial temperature. That is going to be 0 minus minus 5, right? So that is 0 minus minus 5. So we're going to have 1.5 times 2100 times 5. What is that? 1.5 times 2100 times 5 is 15,750 joules. So since that is the energy for the first stage, we can call it Q1 more specifically, meaning that is the energy that is required to change ice at minus 5 degrees Celsius to ice at 0 degrees Celsius. So that is the first stage. Now, what is the second stage? The second stage is going to be here, which is ice at 0 degrees Celsius to water at 0 degrees Celsius. For the second stage, ice at 0 degrees Celsius is to be converted to water at 0 degrees Celsius. So if you analyze, this is a phase change, and whenever there is a phase change, we have to use the specific latent heat. Okay, the specific latent heat, not the specific heat capacity. So the formula to use will be Q is equal to M times the specific latent heat of fusion, F. Since this is a process of melting, okay, the conversion of solid ice to water is melting. So we have to use the specific latent heat of fusion, okay? So that is to say Q is equal to the mass of the ice times the specific latent heat of fusion. So what is the mass of the ice? That is still going to be 1.5 times the specific latent heat of fusion of ice is 334,000 joules per kilogram per Kelvin. 1.5 times 334,000 is 501,000 joules. So since that is the energy required in the second stage, we can specifically call it Q2. So that is the energy that is required to convert ice at 0 degrees Celsius to water at 0 degrees Celsius. So moving on to the third stage, we're going to have water at 0 degrees Celsius to water at 40 degrees Celsius. For the third stage, we have water at 0 degrees Celsius to be converted to water at 40 degrees Celsius. So since it has involved a change in temperature, the formula that we have to use is Q is equal to mc delta theta. But specifically, that will be m of water, that is the mass of the water, the specific heat capacity of water times delta theta. So the mass of the ice is basically going to be the same as the mass of the water because the whole ice is being converted to water. So what is the mass of the water? It is 1.5 kilograms times the specific heat capacity of water is 4,200 joules per kilogram per Kelvin times the change in temperature will be the final temperature minus the initial temperature is 0. So that is 1.5 times 4,200 times 40. So 1.5 times 4,200 times 40 is 252,000 joules. We can call the energy required for the transition in the third stage as Q3. That is the energy that is required to convert water at 0 degrees Celsius to water at 40 degrees Celsius. Now, to finally answer the total energy that is needed, that is Q total, it will be Q1 plus Q2 plus Q3. So what is Q1? Okay, Q1 is 15,750. That is the energy for the first stage, 15,750 joules plus what is Q2. Q2 is the energy for the second stage is 501,000 plus Q3 is 252,000 joules. So if we add all this up, 15,750 plus 501,000 plus 252,000 is 768,750 joules. See you soon in our next video. Please subscribe to the channel, like and share our videos.